Hello students, Dr. Maya Durne here. This is chapter 3. Chapter 3 talk about compounds and chemical bonding. The very first section is the classification of matter, and then we talk about ionic bonding and then ionic compounds and how we name ionic compounds, and then we're going to go to the covalent molecules and then the naming covalent molecules and then the polyatomic ions and the acids. So matter, mainly we can classify matter into a pure substance and a mixture. A pure substance is a form of matter that is like, example, pure substance, it can be water, pure H2O, it's a pure substance. Mixture of substances, it can be like a blood, it's a mixture of substances. Like a sweet tea can be a mixture of substances. So substances can be a solid substance, liquid, or a gas. You need to know the properties of states of matter, where the solids have the particles very close to each other, liquids little bit movement, and then the gases have particles far from each other. The mixtures, the so the matter can classify pure substance and the mixture can be one or more substances, can be homogeneous, heterogeneous. Homogeneous is like sweet tea, you dissolve sugar in water, you dissolve salt in water, it's a homogeneous mixture. Heterogeneous is you mix some salt and sand, so that's going to be heterogeneous mixture. So when we do the measurements, they can identify the quantitative and the qualitative. Quantitative always expressed with a number. Qualitative is without the number, you use the color, amount, like that. And then there are two types of properties: physical property, chemical property. Physical property is like melting point, boiling point. You don't change the substance. Example, you melt. Just water is melting, right? Water is boiling. But the chemical property is like burning, rusting. So this is the end of the section and this is a review. So please study the PowerPoint and the videos and I hope this is helpful to know the matter and the classification. And next, I am moving to very important concept which is ionic bonding and then the ionic compounds. What is ionic bonding? Ionic bonding is the bonding between a metal and a non-metal. Metal loses electron, non-metal gains electron. Metal loses electron and becoming a cation, non-metal gains that electron and becoming a anion. So when in ionic bonding you have a cation which is positive charge, anion is negative charge. So interaction between this anion and cation, we call this as the ionic bonding. So this is the ionic bonding formation. Sodium, which is a metal. How do you know it's a metal? Remember the periodic table, we talk, okay, these are the metals, these are the non-metals. This is a metal and this is a non-metal and the electrostatic interaction between a metal and a non-metal form ionic. Always, so the compound is neutral. In order for the neutralize, it should be like one positive charge to one negative charge. So how? So the writing ionic compounds is important. The way you write it. Um, so you write. So always the charges cancel each other. How do you write the ionic compounds? So you call ionic compounds like sodium chloride, magnesium chloride, like that. So let me take a simple example and show you how to name these ionic compounds. And I have a separate video of a complete nomenclature, but I'm going to explain here too. But I highly recommend you to watch that video as well. Okay, computer, give me a minute. Okay, so If you see this compound, it's lithium and sulfur. It's lithium sulfate. Sorry, lithium sulfide. So here it's a compound between lithium and sulfur. Lithium is +1 charge, sulfur is 2 negative because it's in the periodic table, it loses 2 electrons. So it's lithium and sulfur, lithium sulfide, barium chloride, aluminum oxide. I want you to take the where the periodic table is and then show you how these how do you determine the charges. So I want to see where's the lithium in the periodic table, which is Li, group 1, always form +1 charge. Look at where's the sulfur. Sulfur need these, why these elements form bonds? Because they want to go to the closest noble gas. So sulfur need 2 electrons to go to the noble gas configuration. Because it's gained 2, electron charge is negative. So you write 2 negative. Lithium plus, it's a metal, sulfur 2, lithium, sulfur combined form lithium sulfide. But there is a way you write it. Let me connect this to the, I hope you can see now. It's lithium plus sulfur 2 minus lithium sulfide, and then there's 2 always. It's easy way this, you switch the charges. Charge of sulfur goes under lithium, charge of lithium goes under sulfur. Here the charge of lithium is +1, you usually don't write 1. And then if we go to the magnesium chloride, which is magnesium in the periodic table, it's +2, Mg +2 because it loses 2 electrons, Cl minus. Now think magnesium chloride, you switch the charges of cation and anion. Magnesium is charged 2, you write under chlorine, MgCl2. We look at another one, aluminum oxide, ALO, aluminum group 3, form 3 plus, O2 minus because it needs 2 electrons, ALO 2, 3 by 2. This 2 goes under here, this 3 goes under here. That's how you switch it. So that's how you write the names. But how do you name it? You don't write. When you name it, you write aluminum sulfide. You write aluminum sulfide. This 2, no, you don't write 2 aluminum 3 sulfide. No, you just take the 2 names of the elements and then you write it. You don't take the subscript to the account. Don't take it, just write aluminum sulfide. Example here, our first one, magnesium chloride. You write magnesium chloride. You write lithium sulfide. Always see the first one, metal, you write as a name, lithium. And then you look at the non-metal, which is sulfur, you write sulfide, lithium sulfide. So that's how you do the naming. That's how you write the names. So that's, hope you understand that. And if I go back to the this one, so you see all these, I explained that. And then binary, so there are 2 types of ionic compounds. Some certain metals, they form more than 1 type of cation. So all these metals listed in this periodic table form more than 1 type of cation. But you know, right? But if you think about group 1, always the metal form +1. Group 2 always form +2. Group 3 form +3, like aluminum, right? They form +3. But these are metals in the mainly the D block. Transition elements, metals, they form more than 1 type of cations. Example, chromium 2 plus, chromium 3 plus. Mn2 plus, Mn3 plus, iron 2 plus, iron 3 plus. Like that, they form more than one type of cation. How do you write when they form more than one type of cation? If there is this kind of cation, you always need to write the charge. Let's see what is that. So I have it here. Let me see whether I can write on it. So here it is chromium. Uh, Here, and I'll take the question. So write the formula for the compound that would form Fe2 3 plus Cl. How do you do? FeCl3. Why? You write iron, you write chlorine, charge of the chlorine goes under, charge of the iron goes under chlorine, charge of the chlorine goes under iron. Fe2, so then 2 is just cancel out. Like that, you write the name. So how do you name it? Chromium, so 2 iron, chromium 3 iron, like that. So that's how so calcium 2 iron, lead 4 iron, it goes like that. So this is some iron. So there's Al3 plus, barium. So some how do you name some common cations? I mean, this is like obvious, right? So you write aluminum 3 plus, barium 2 plus, like that. So and then anion, always you write "ide" at the end. So the easy way to know it, let's take a compound which is aluminum oxide, Al group 3, you write 3O, aluminum oxide. So how do you name it? Aluminum, you write the metal name, and then you write oxide. So the metal name, anion plus ide towards the end. Non-metal, you don't write aluminum oxygen, you write aluminum oxide. You don't write sodium chlorine like for NaCl. For NaCl, you write sodium chloride. If you write sodium chlorine, that's wrong. Let me show you some mistakes that my students I have seen. So MgCl2, how do you name it? Magnesium chloride. Some students write, okay, magnesium chlorine, wrong. Some students write magnesium, and it can be multiple choice question as well. 2 chlorine, no, no, you write, how do you write? Magnesium, no 2, chloride, magnesium chloride. So that's how you name it. So these are some anions and then some compound names. And then if it is a compound with more than one charge, I showed you, you write cobalt 2 chloride, chromium 3. How do I know? By looking at it, because you switch the charges. So the charge of chromium goes under oxygen, charge of oxygen goes under chromium. So chromium 3 oxide, like that. So determine the name of each ionic compound. Calcium nitride, magnesium chloride. Copper is the one atom I showed you in the periodic table that move for more than one type of cation. So here is the copper. Copper is here. You see copper 1 plus, 2 plus. So you go down. Copper 1. How do I know it's 1? Because I find copper charge under the oxygen. So there's no, so it's copper 1 oxide, zinc chloride, and then manganese 3 oxide, lithium phosphide. Like that, you name the ionic compounds. Please watch another video. I have a complete video of nomenclature as well. So I'm going to the covalent compounds. Covalent compounds are the compound made out of 2 nonmetals. The other one is complete ionic compound, complete transfer of electron from metal to non-metal. Here they share 2 non-metals share electrons. So example, hydrogen, chlorine, water. So always this one we learn about the law of definite proportion, law of constant composition, which shows a different sample of any given compound always contain the same element with exact same mass ratio. Example, carbon monoxide, carbon dioxide. CO2, like always 12 grams of carbon combined with 32 grams of oxygen. So then there are some molecules like diatomic molecules, polyatomic molecules. Like diatomic molecules are these: um, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these are the all the diatomic molecules. Okay. Okay, so I was looking at the way of finding diatomic molecules. It's easy way. It is have no fear of ice cold beer. I thought I stopped. I post the video. Sorry. It's have no fear for ice cold beer. Those are the diatomic molecules. So this is how you find the diatomic molecules. And then there are some polyatomic molecules as well. And then the other one is mainly we use the molecular formula to represent a molecule. And then sometimes this empirical formula. Empirical formula is the smallest whole number ratio between atoms. Example, hydrogen peroxide. We use to clean wounds. It's the molecular formula is H2O2. H2O2 is like that's not very commonly used, right? So actual formula, but empirical formula, smallest whole number ratio. We use this empirical formula only for calculation purposes. So write the empirical formula. So if I ask you this kind of a question, you find the common factors C6, H12O6. You see it's 6, right? So it's CH2O, adenine, CHN. N2O, you cannot simplify anymore. It's already simplified. It's N2O, same as the molecular formula and the, empirical formula is same for that particular question. Okay, so I go down a little bit. And then I'm going to stop the first part of the video and then coming back to the next part in the second video. And now, so next one we got talk about the nomenclature. Thank you.